Unfortunately for me, this display, the one that I've been using as my magic mirror display in my living room, which is actually a really cool thing, highly recommend you make one of these, just a Raspberry Pi and a display, it's great, for like 5+ years has kicked the bucket. It won't turn on, the power LED turns on, but it just won't display anything. If I connect it to a more sophisticated machine rather than a Pi like my laptop, it definitely is doing something wrong with especially HDMI. And so in the process of me trying to fix this, or at least get it working again, I was taking it apart and I found it really cool to see all of the individual layers, what makes up a monitor like this, and even just testing some of the bits like the backlight. It was really cool to see. I found it really interesting. And since I talk so much about monitors, I figured that this is a great opportunity to take this one apart again, show you what's actually inside your monitor, test a few things out, show you how they work, and generally just hopefully feed a bit of interest, because I think this is really cool. So what I'm going to do is take this apart. I'll stick some music on because that's the least interesting part of this whole thing, and then we will show you what's inside, talk through it, test out things like the backlight. So yeah, without further ado, cue the music. Let's get this thing apart. This is actually really only 2 pieces, or I guess 3. You have the panel itself, and then under that is a little metal housing which has, in this monitor's case, the power supply board and the digital board, the one that takes in your inputs and sends them out to the panel. So what we're going to do is pop this panel out, disconnect the backlight wire and the signal or display wire, and then we can look at the 2 parts, or 2 sort of halves, separately. See what I mean about it not being connected to anything? I just lifted it up. There is, however, a couple of screws I need to take out so that I can take the wires out, so let me do that first. It's probably also worth mentioning that because this monitor is dead, and I'm pretty sure that it's not ever going to be able to be revived, at least without a replacement part, which I don't think I can get. I'm not being as gentle as perhaps you might be if this was repairable or this was something that you cared a bit more about. And I've also had this open already, so I know what's in here and I know the condition and the state, so yeah. So just to be clear, this board here is the power supply board, and these 3 pins are live earth and neutral in one form or another. If you were to have this still plugged in and you touched any of those conductors, you will get a mains voltage shock. It will be fused at 13 amps, but funnily enough, 13 amps is enough to kill you, so be sensible. Also, here's our 2 boards. We have our power supply board and our digital board. Now in my monitor's case, it's the digital board that I'm pretty sure is dead. However, let's get these 2 out so that I can show you more of what's going on here. Also, in our monitor's case, there is a grounding strap we need to remove to be able to disconnect the monitor's data harness. So let me remove that screw. And then the data harness just lovingly, forcefully pops off. As for the backlight, it's just a tiny little JST connector, which is actually kind of funny when we talk about how much power the backlight uses. Okay, so we now have a panel and a power supply and a scaler. Let's start with the scaler and power supply, and then we'll come back to the panel, because honestly this is the coolest bit, so let's save it for last. So this is actually the connector for the buttons and LED down the front. I initially thought that this was just a really simple, power and then whatever, but there's not enough wires here for each one of these buttons to have its own sort of signal. So either it's power and ground for the resistor, or well, power and shared ground for everything, and then a couple of multiplex wires, or there's a little microcontroller on there. We can take that out in a bit and see, but let's get the power supply and digital boards out first. So this is our digital board. This is what takes our inputs, which if I show that to the close-up camera, you can see all of our inputs there. So we have HDMI, DVI, and VGA, as well as audio, I think audio out. And then the board itself is relatively simple. So you have the big chip that's in the middle there is the main scaler. So that's what's taking all of your monitors, like all of either the digital or potentially analog signals in, and then like converting, like doing all the processing. So when you change the brightness, or when you change the color temperature, when you do change the sharpness, this chip is the one that is doing all of those modifications to the image, and then it's sending that out via the display connector up here. It's actually all annotated on the back as well. Hopefully the camera will pick that one up. You can also see just how much heat this chip generates by the fact that they've put a load of solder pads on the back as a heatsink. So yeah, there you go. The main power for this board comes in on this connector here, and I suspect that this is one of the problems with this board, but we'll get back to that in a second. And then this is the dangerous one. So this is the power supply board. It takes your kettle lead in here, transforms it down to a usable voltage. It will rectify it somewhere on there, I can't quite see right now. And then it will output, in this case, it outputs, in theory anyway, 12 and 5 volts. And so we have the big death capacitor, which is this one here, if I move the cables. This is what I was talking about with the whole reference to mains voltage. When charged, this capacitor will be like enough to shock you for sure. Maybe even enough to kill you, who knows? So try not to touch stuff if you don't know what you're doing. Also, you might notice that there is a capacitor missing here. That is because that became a spicy pillow and was just about to explode. These are electrolytic capacitors, so there's actually a fluid in here, and as over time that the barrier between them degrades, and then it creates pressure and wants to go boom. So yeah, best to avoid that where possible, and so I took that one off in hopes that that was causing at least some problems, but sadly not. You might be wondering why I disconnected the backlight from this power supply board and not from the digital board, the one that's technically controlling it. And the answer is that the controller doesn't take much power. In fact, this board actually only takes in 5 volts. That's it. This board, on the other hand, produces whatever voltage is necessary to run the backlights, and we'll come back to that in a second, which is where all of the digital circuitry on the back comes in. So you have what I believe is probably a microcontroller down here that's handling that. There's actually one of the main pins here is a PWM signal that comes from the controller to the sort of power supply board, which will then regulate the backlight. So when you dim your monitor's brightness, especially on cheaper monitors like this, the way that they do that is by flashing the backlight on and off really quickly. The faster they do it, the better the quality generally, but the point is that if you vary how much of the time the backlight is on as it's flickering, you vary how much brightness you get out of it. That's called PWM, or pulse width modulation, and it's generally frowned upon in terms of the sort of user experience because it can be flickery. We've had flicker-free monitors for a while. That generally just means that they put a whole bunch of capacitors in line to make it smooth. There are ways of doing digital or sort of actually analog voltage control rather than straight PWM, but anyway, we're getting off the point. Point is that probably that MOSFET actually is flicking the backlight on and off based on the controller board's requested voltage, which comes over one of these wires here on the PWM line. As for what's actually wrong with my monitor, I have a sneaking suspicion that it is something on this board. I measured the ability, like this power supply board's ability to produce 5 volts just fine, so this board is getting powered. The fact that the LED turns on means that this board is working, but it gives you what I think is a diagnostic code flash. Although I'm not exactly sure. It does flash at different rates depending on what might be happening to it. And so I think this board is dead. If I can find a replacement for this board, that would be sweet. But otherwise, it's kind of annoying because the monitor is otherwise perfectly functional as far as I can tell. But let's dive into the panel now, because by far that's the coolest part. Oh, and also if your monitor has built-in speakers, they might look something like that. That's 2 2-watt speakers for you. So our panel. This is a 1080p 60Hz IPS panel, if you were interested, and generally speaking, or actually specifically with this panel, this is an edge lit panel. That's quite common, especially for monitors like this, which we'll find out what that means very shortly. We have our backlight wiring and we have our display wiring. Now, it might surprise you to find out that your monitor scaler board doesn't actually give perfect instructions for the panel. The panel isn't directly connected to this. It's actually connected to more chips that are on a little PCB here. Let me take off this very noisy film and I'll show you. So hopefully you can just see that. In fact, if I tip it up, you'll be able to see that on the other camera here. We have another circuit board here. This circuit board is the one that takes the data from your processor board and turns it into the connections, if you see all these ribbon cables down here, for the actual panel itself. This is what does an awful lot of the work, and let me just disconnect the connector for it. We have a few other layers that are going on in here, so let me take this further apart and you'll see what I mean. So with the frame out of the way, I think you can have a better look at that circuit board down at the bottom and all the ribbon cables that are down there. And then if I very carefully now flip this back over, we have minus one more bracket that needs to come off, basically the whole panel. So you actually have the side ribbon cables here so these are the verticals, these are the horizontals. Yeah, got that the right way around, I think. And so if I very carefully flip this up, you will see that what we have here is the liquid crystal panel. So this is the actual LCD. This is what does the displaying. And I'm gonna get some close-ups of this later, but you can see right on the edge all of those micro connectors for each one of the pixel rows, which is really cool to see. And if I flop this down, so this is an LCD bonded to glass, or probably more like plexiglass. You can see the difference there. But behind this is the backlight, sort of. We actually have a whole load of layers, so let me pop this final bracket off and then we'll have everything out. Right, this is it. This is every layer in the monitor. So we have the LCD and the sort of front glass. We have a sort of distributing Fresnel layer. We have another Fresnel layer, which if you don't know what a Fresnel layer is, this is like if you see and then you don't see, and then you see and then you don't see. It's basically a for like microstructure that lets the light be distributed really, really well. Flip that the right way around. Then we have a, just regular diffusion layer. So this is just, slightly misted white. We have a thick bit of plexiglass. This is just clear acrylic, which you will understand in but a moment. And then we have the final layer in here, which is literally just a white sheet of plastic. White sheet of very thin acrylic, and that's it. That's it. This is just the backing to the panel. The real magic is actually down there. I don't know how well you will see this, so I will get some close-ups of this as well. But down there is, I haven't counted exactly, but something like 80 little white LEDs. That is the backlight. There is not any other form of light back here except for this tiny little strip of LEDs. This is what's called an edge lit display because it lights from one edge. That's pretty much it. There is a strip of LEDs, and then as we will see in a second, the monitor can actually do a really good job of diffusing the light that these generate up and across the whole panel pretty evenly. Now it's more likely to be a little brighter down the bottom just because of, well, the laws of physics, but that's pretty much it for an edge-lit display. There are actually a bunch of different backlight technologies, including, for example, if you have a larger and especially slightly thicker, older TV, you often find that they have just individual LEDs across like this backplate kind of thing that are bigger, that are heat sinked, although this does act as a heat sink. That's an aluminium circuit board to dissipate the heat. Or if you have something like a mini LED backlight, that will be, again, the whole backlight with a film kind of like your LCD for those miniature LEDs. Or of course, if you have OLED, then you have none of these things, you just have the panel itself, because the panel itself is also the backlight. You might have also wondered why my digital power supply has been on the desk this whole time, and that's because we're gonna power the backlight, we're gonna power the panel, and this is really cool. I did this while I was like trying to work out what was wrong. I was testing each individual LED, and I wasn't getting a resistance reading across the whole thing, and so I thought, well, this is a bit weird. Let me just try giving the whole thing some power, and it turns out that that works really well. What we're gonna do is just power it up, and then I'll add layer by layer so you can see what difference that makes. Let me start by just hooking it up. I have my digital power supply, which is current limited, which is really handy. All the usual protections like short circuit and that sort of thing. And the nice thing about having it being current limited is that we can then monitor and control how much current goes in to be able to control basically how bright this thing gets. So if I start with this nice and low, so the way that these LEDs are connected is all in series. Each LED is, a couple of volts at most. You can check the data sheet for these specific ones if you want. But because we're looking at like 80 of them, we actually need quite a lot of voltage. So we're at 35 volts right now. Nothing's happening because there's no power flowing. If I gradually increase it, at some point, we will get some power. So there, 44 volts, and the LEDs just turn on. We're only drawing like half a watt for the whole thing right now, but that's also because we're only drawing 19 milliamps across the whole thing. As I gradually increase it, well, we gradually get higher and higher brightness until we reach constant current, and they're at half an amp per LED at 56 volts or 30 watts. That's pretty bright. I'm gonna dim it back down a little bit so that it's a bit more comfortable for me to look at. So putting our first layer back on, which is just this sheet of white plastic basically, what you see is that this gives you a lot better like reflectiveness for the backlight. So instead of the backlight trying to fight against what is very shiny but not exactly mirror polished metal, we have a perfect white light to go off of here. So with our white piece of plastic in here, what we get is a very perfect flat white and a bit more diffusion across the edge, but not that much. If I increase it slightly, you can see it's definitely more even, and it's also helping to shine the light forward more as well, but not much has happened yet. Where this gets really interesting though is the bit of acrylic, because I was actually a little, perhaps underselling how important this thing is. And also the one key thing that this has different from just a sheet of cut acrylic. If I put this down, you'll see exactly what I mean. Once it goes in, it lines up with the tops of the LEDs, and as if by magic, if I get it in the right place anyway, turn it up a little bit more, we have a perfectly flush light. It looks like this is a perfectly emissive panel now, which is incredible. If I turn it up some more, this is just a flat sheet of white now. How cool is that? The way that this is working is the mixture of glass fiber, fiber is in your internet. Those work by shining a light through, or normally a laser, through a piece of glass fiber, sometimes even plastic or acrylic like this, and using the total internal reflection to bounce the light all the way through. Well, this is doing something similar, except there is actually a micro texture etched onto the back of this. So as the light shines through the bottom edge of this acrylic panel, it is then being not only shot all the way through the panel, but it's also hitting that micro texture and bouncing up and out of the panel, giving you uniform light from a single tiny strip of LEDs. How cool is that? The other layers are pretty cool too. This is just a diffusion layer, which gets rid of that grainy microtexture in favor of just smoothing it out. And as you can see, all of my fingerprints, if you were putting this back together properly, you would want to clean that or wear gloves when you're taking this apart. But because I don't care that much, and this monitor's dead anyway, I'm gonna leave it as is, as great illustration of what you shouldn't do. Our other layers are the Fresnel layers. These make the light incredibly uniform. If I drop this down, you can see just how amazingly clear this now looks. Well, if you can't see this, I certainly can. This is really cool. You can actually really clearly see how the Fresnel layer sort of changes the light that's behind it. I can actually see, from where I'm sitting anyway, the diffraction of blue, yellow, sort of orange, red, green, red, and then a sort of mirror on the other side. This is what the Fresnel Fresnel layers are doing. They are diffusing the light so that you get the most clean and uniform brightness you possibly can. If I pump this up a little bit, you'll see that even more clearly. This is just a straight, perfectly clean set of light, which the panel then takes, blocks most of it out, by the way, because if you haven't noticed, this is really bright, and this is about the power that this panel takes when running at full brightness. So this is, what you would see, but the monitor is actually blocking the vast majority of this light out. Even this IPS panel, this is probably in the order of hundreds or maybe even 1,000 nits of raw brightness, but you're only getting 100 or 200 nits out the other side. That's what liquid crystal panels do to the backlights, and that's why you end up drawing a whole load more power to power your display than you otherwise would if it was just a straight LED. And now we have the panel sort of back together. It's not actually put back together properly, but I think this is a really interesting demonstration of a few different things. IPS monitors in particular used to be really bad for basically edge bleeding, light bleeding around the edge of the panel and then showing up as sort of glowing around the edges. And this is why. You have a backlight that is shining permanently whenever the monitor is on, And then even if you're asking it to display nothing, which I am now, there is actually some light still coming through here. So that's like IPS glow, that's the failing to block light. But if you don't perfectly seal around this edge, which is what I think this frame is meant to do, and actually I think does a decent job at it, especially because there's like literally rubber gaskets that help seal it, you get light bleeding over the edge. And if you don't design the panel itself, including the backlight, to block out that sort of thing, like again, literally having rubber gaskets between the actual backlight and the panel itself to seal that, then you're gonna get backlight glow. That's why like panels have definitely gotten better, because they have designed for that sort of thing since the original panels. But yeah, I think this is really cool to see, especially that diffusion layer, but even just building up layer by layer, you can see the quality of light changing. And I think that's really, really cool. Hopefully throughout this video, I'll have added some extra information on screen for you as we go through each of the layers. But the long story short is very much that. You have the panel itself, the LCD, the liquid crystal layer. That's the one that has your actual pixels in it. That's controlled by all of these data lines. Let me just turn the power down a little bit on that. And these data lines over here for the horizontal. You have a little circuit board on the back that takes data from your scaler, and your scaler is powered from the power supply board. And at least on this edge-lit backlit display, you have just a single row of LEDs down the bottom, and then you have a whole bunch of layers to make that a uniform and good looking like backlight source and then final picture. I do really like finding out how stuff works. It's one thing to know the theory behind what goes into stuff, but to actually see it and have a play with it, I really enjoyed. I really found this cool, and I hope you did too. If you have any questions, feel free to leave those in the comments down below. If you want to see probably not more videos like this one specifically, but more just talking about tech, reviewing monitors, or my own testing tools, the open source response time tool that you can use to test monitors, or actually liquid crystal response times, just like this panel here, then feel free to head to osrtt.com, linked in the description. I make them right here at home, ship them worldwide. Feel free to pick one up. Also, if you want to see more videos just in general, there's a subscribe button. There's plenty of videos on the end cards. And yeah, thanks for watching. Hope you enjoyed it. I hope it was all right to watch. I'll see you on the next video.